Hyperion, making the world's software safer. During this video, we are going to give you a powerful demonstration of Hyperion analyzing a simple calculator program with an embedded sleeper code. This is just a simple demonstration of our Hyperion software, and for the purpose of this demo, we are using a piece of sleeper code designed to evade common signature-based technologies such as McAfee and execution-based technologies such as FireEye and Invincia. For this analysis, the embedded sleeper code will do a few simple things to evade anti-sandboxing technologies. For example, the sleeper monitors mouse movements and continues to sleep until it sees any combination of numbers that calculate out to 666. Also, to evade scanning-based technologies, the sleeper is scattered throughout functions of the program. The power of Hyperion is noticed when the analysis is done, and you realize not only did you receive a full analysis of the malware, but you also immediately received actionable indicators that can be used to fingerprint the malware itself. This facilitates faster response, defense, and prevention actions. Next, we will upload our sleeper code embedded in the calculator program to be inspected by 56 different malware detectors on VirusTotal. The report reveals that only 1 out of the 56 scanners actually found anything malicious with the calculator program. The only detection was classified as adware, and we believe that was due to the callback inside of the program. Notice, none of the other detectors were able to find anything malicious with the sleeper code. Now we'd like to provide you with a unique example of software assurance combined with malware detection and analysis being calculated by the advanced analytics of behavior computation for application security software. We start with the computed representation of the simple calculator program. I would like to point out a few important items in talking about software assurance. As you notice, we provide a full understanding of the program structure. You see the name, file type, structure, one main, and 389 functions, and all the hash values associated with the program. We give a rating based on whether it is malicious, suspicious, or not malicious at all. We pinpoint exactly where the malware is residing inside of the program. We define the malicious behavior. And we provide network observables. Network observables are the things you would be able to observe if you actually ran the program dynamically. With our malware analysis and detection, we don't just state that it is malicious, we also provide you with the specifics of why. We are now provided a flow report to inspect. Here is how we address anti-sandboxing in our analysis of Hyperion. As you can see, we are giving the type of technique used. So we are not just simply identifying it as anti-sandboxing, but we go a step further to tell you exactly how the anti-sandboxing is being carried out. From a threat intelligence standpoint, you are now able to better understand your malware and relay that back to threat actors. We have demonstrated Hyperion fingerprinting the malware in the simple calculator program. Once Hyperion has fingerprinted the malware, then, through a post process, it puts those fingerprints into customizable formats readable by host and network-based cyber tools. In this case, we are using ClamAV. For Scenario 1, ClamAV scans the infected simple calculator program and a variation containing no Hyperion fingerprints. As we see here, it finds 0 files to be malicious. For Scenario 2, Hyperion formats the fingerprints and ingests them into ClamAV. Now ClamAV runs the scan using the fingerprints, this time finding both the simple calculator program and the variation to be malicious. Now we can demonstrate how Hyperion formats its malware fingerprints of the sleeper code, which are embedded in the simple calculator program for use in Yara-based technologies such as FireEye and Invincia. This concept gives execution-based technologies a clear advantage by utilizing a more powerful fingerprint versus a traditional signature to reduce the effectiveness of their limitations. Next, we can demonstrate the power of Hyperion malware fingerprints versus the traditional signatures in more detail. We want you to see both the consistency of the fingerprints and the high fidelity that Hyperion provides. To do this, we have 8 samples of the Virus malware family, and we are going to pull 2 of the samples to allow for observation of the following. Scenario 1. ClamAV scans all 8 samples with a 0 detection rating. Scenario 2. We take 1 variant from the Virus family and upload it into VirusTotal. As you can see, only 6 out of the 57 scanners find the file to be malicious. Please note, McAfee, Bitdefender, ClamAV, Kaspersky, and others don't find the malware to be malicious at all. Scenario 3. Hyperion generates a malware fingerprint for ClamAV. We use just one sample. Scenario 4. Using the one fingerprint created from virus samples, we ingest that fingerprint into ClamAV. ClamAV scans all 8 samples again, this time finding all 8 to be malicious, demonstrating a higher fidelity. Now we take virus sample and upload it into VirusTotal for consistency. While, once again, not all of the scanners were able to find variants of the virus family to be malicious, ClamAV, using malware fingerprints created by Hyperion, did. This is the power of Hyperion. We hope you have a better understanding of our Hyperion technology. Thanks for watching this demonstration. Hyperion, making the world's software safer.